will go through the what are all the projects courses available with Skill Designer. We just go brief with that particular details, and then we will go into the concepts. Okay.
Yes, sir.
So in Skill Designers, we are having job-oriented courses which lead to opportunities like exclusive for finalists, passed out students, and 90 days online courses, certifications, everything will be available. And also internship will be available for all the second year and third year students. And also the certification also will be provided by Skill Design team. So job-oriented courses like full stack development courses, EV technologies, embedded plus Python courses, civil structure designs, electrical design courses, mechanical design courses will be available. For CSC, IT and IC students, cyber security, data science, artificial intelligence, machine learning, deep learning, blockchain, full stack Java, everything will be available. So for EC and ENT, embedded systems using Python, Internet of Things, VLSI and PCB design courses are available with Skill Designers. So for electrical students, electric vehicle, industrial automation, substation design, solar plant design, everything will be available for electrical students. For civil, parallelly SDS2, structural analysis and design using STAAD Pro, revisit architecture, design of building using ETABS will be available with Skill Designers. For mechanical, automobile and aeronautical students, space, light, flights, drone technology, 3D printing design, production design, SolidWorks, electric vehicle concepts will be available. So you can, for more details, you can contact this particular phone number. Okay. Guys, am I audible? And I thought you are listening everything.
Yes, sir.
Thank you.
You're audible, sir. Please continue.
Yeah, thank you. So going to the electrical vehicle concepts, now we are directly entering into the EV concepts. Okay. So you all are aware that we are in BS6 in IC engines, and now we are parallelly moving into pure electrification of the vehicle. Okay. So in future, electric vehicles are playing a prominent and important role. So why electric? So we are having petrol, diesel. Okay. So why we need electric car? Because ecologically, with the IC engines, we are having a global warming. You know, we know well. So to avoid all these things, and also for cost, easy mechanism and economic, so cost of the ownership will be reduced by using electric cars. So how it is going to reduce the cost of ownership and ecological imbalances has been reduced with electric car. We will go inside the concept, then we can understand. So earlier in 1884, Thomas Parker built the first practical production EV car in London. So the concept of EV vehicle was started in 1884 itself by Thomas Parker. So later 1897, electric taxi, William Morrison, New York. So electric taxi has been invented by William Morrison in New York. So later on 1990, few automobile companies like BMW, Ford, Echo, Star, GM has been started investing on EV to develop the electric vehicle. So in 2008, Tesla has been invented new technology in EV and has been launched the EV in the automobile industry for the first time. So practically it was successful in 2008. If someone has unmuted the microphone, can you please mute? So practically in 2008, Tesla has launched the vehicle and was successfully running from 2008, and later on in 2022 almost our Indian manufacturers also has been started manufacturing and delivering with a success rate of almost 50% sale rate. So in this, with a 100% average, the sale of EV in India was almost close to 50% currently. So any doubts regarding this?
Hello, sir.
Yeah, Emma. Yes,
Good evening,
please.
sir. I had a small query about regarding the electric vehicles, sir.
Yeah, please.
Sir, do India had started using electric vehicles?
Yeah. In 100% sale rate, we are close to 50% of sales in EV, like Mahindra, Tata, MG. MG is an outside of Indian company, MG, BYD, Audi.
Yeah.
So as an Indian manufacturer, Tata and Mahindra are having highest sale rate in India. So currently Tata is having more electric vehicles like Nexon,
Yeah.
Tiago, Tigor. These are the current running models. In Mahindra, Verito is already there from 2019, but somehow they have stopped the production of Verito, e-Verito, and now they are coming with XV400.
Wow, that's good. Then
In
what
this-
about Tesla, sir?
Yeah, Tesla outside India, Tesla is a successful company which was running with a success rate of 100%,
Okay.
but they are planning to launch Tesla in India.
That's
Might
good.
be the chance of their production will be start in the financial year of 2025.
Yeah, that's great. That means most of the electrical students are going to be beneficial from
Yeah,
that,
yeah.
no?
Not only electrical students, electronic students, and mechanical students are going to have a great opportunities in electric vehicle segment.
That means you want to say that the core subjects are going to be leading the world in
Yeah,
the coming years.
definitely in an EV vehicle we are having electronic components, electrical components, as well as mechanical components. So any manufacturer will see the local production of the particular child parts. So obviously the vendors will be increased in the Indian companies. So obviously
Yeah.
we'll get good opportunities.
Yeah, thank you, sir, for clearing my doubt, because most of the things the avoiders are going out like core concepts are going to be declined. I know
Yes.
the IT sector is going to be wondered.
Yeah.
So, but you will be a realization of that.
Yeah, but in future we are going forward in commercial segment also we are going with small trucks already in trial run. Small light commercial vehicles like Tata Ace, Mahindra Maximo truck, our trial runs are going in the year in the 2023 or 24. We are getting those light commercial vehicles also in EV.
Okay, so there might be a very good opportunity for all of the people
Yeah.
of that, no?
In further, we will get heavy commercial like lorries also we are getting,
Complete of electrical type.
yes. But not yet started production, but they are planning. All the OEMs are planning for electrifying the system.
Yeah, yes. I had recently heard that it is also one of the planning of the our Indian Financial Minister like Nirmala Sitharaman.
Yeah. So currently you have heard that in this financial year, all the EVs having some cost reductions in
Yeah.
the budget. So the production from coming months, the EV production will be increased, and the requirement of the people, sale, everything will be high because of the cost reductions. So in coming future, definitely there is a huge scope of opportunities for EV and electrical vehicles. So obviously we will get good opportunities for electrical students, electronic and mechanical students, as well as automobile.
Okay. Thank you, sir, for creating such a hope like this,
Yeah.
like telling all these things.
Yeah, sure.
So, yeah, please continue.
So can we go for a second slide?
Yeah, definitely.
So working of an electric vehicle, how it will work? So since we are aware of that IC engines now. So in IC engine, there is a petrol and a diesel compositions and automation of the either petrol or diesel. The internal combustion will happen and the power will be generated in IC engines. So, but in EV, there is no IC engine, no fuel, or nothing input from fuel side. So only thing was we are having a battery, which was the source, and a component or main components are controller, motor controller, and single speed transaxle or gearbox. So, hello, am I audible?
Yes, sir, you're audible. Please continue.
So for an electric vehicle, these are the main components without an IC engine. So the pollution, the cost of fueling, everything will be reduced. So how an electrical vehicle will work like, so it will take the power from the battery, which was stored with the DC current, and the power was transferred to controller. From controller, whenever the driver requests with an accelerator pedal, it will move, the power will move into the motor and then it two wheels. So this is the easy and easy technology which will having a less cost and we can use the renewable sources also in EV. So may I know any doubts in this slide?
Sir, can I let you one doubt?
Yeah, please.
So you are saying that there are some renewable sources are involved in that. So
Your
you try
voice
to
is
apply.
somewhat getting slow.
Yeah, okay. Sir, you explained that we are going to use some of the renewable sources for the production of the electrical vehicles.
Yeah.
So in what concept you are telling that how we can use the renewable sources like for battery charging itself?
Yeah. So we are aware of the solar system,
Yeah.
and in electric vehicle, while we are not using any, while the vehicle is rolling normally. Okay. So regeneration is a concept included in the electric vehicle. Okay.
Yeah.
So whenever we will getting the vehicle downward direction. So
Yeah.
the motor will give back the power to battery for recharge, even in working condition. And second thing, like solar system, if we are having solar system in our house, then the power consumption will be reduced and the cost of ownership will be very low.
Reduced. Yeah.
Yeah, okay.
Yeah, okay, sir. Completely. Thank you.
So in electrical vehicles, we are having two types. So one is pure electrical vehicle, and currently we are having hybrid electric vehicles. So what are the differences between hybrid and electric vehicle? So electric vehicle is having only battery, motor and transaxle or gearbox. So without any tailpipe, like no emission, zero emission. So whereas in hybrid vehicles, we are having both IC engine parallelly as well as EV, electrical components. So we can use both the components. So that, we can use both the electrical and as well as petrol or diesel. No, currently we are having only petrol in hybrid vehicles. So we can see the hybrid vehicles like Hyrider has been launched by Toyota, and Kona is already by Hyundai. So currently in our Indian market, we are available. We are having these two models available. So any doubts in that?
No, sir, it was clear. Please continue.
So in hybrid system, we are having two types of architecture in the vehicle: parallel hybrid system as well as series hybrid system. So in parallel hybrid system, we'll having a battery EV parallelly IC engine. But in series system, it is having first it is run through motor, converter and battery as well as a generator which was fixed in between the engine and the gearbox. Can I move forward?
Yes, sir.
So how does the electric car charge? By plugging in the electric socket, by taking from the grid, the electric car will be charged. We can charge an electrical vehicle by plugging into the public stations, home chargers. So two types of charges will be available. One is AC charge and DC charge. So we will charge at home, that will be in AC charge, and whereas in public stations we are having like bunks, we are having in some metro stations, in some parking areas and in malls. So those are DC charging stations. The capacity of the DC charging stations will be high, and whereas AC charging will be available, we can use in home itself. So is there any doubt in this slide?
No, sir.
So comparison between electric vehicles and conventional vehicles. So from electrical vehicle, electricity produced by battery, energy was been given by battery. For conventional vehicle, it is through fuel. Price is not expensive for electrical vehicle, and the battery maintenance will be high compared to conventional vehicles, cheaper due to more availability of feasibility and of resource. So why this is happening? So while charging the battery, it will take more time, compared while conventional vehicles, IC engines, we will go to the bunk and we will fill the fuel within 5 minutes. So this is the one of the drawback for EV vehicles. So while going to the pollution, there is no pollution exhibited by electric vehicle, whereas harmful gases like NOx will be generated inside the IC engines. Running cost we will discuss in the future slides. So here it is IC engines versus EV. In IC engines, high pollution emission, single energy resource, multiple gears, fuel economy is low. Am I right? So while moving to EV, zero pollution, there is no tailpipe for exhibiting the pollution. Multiple energy resources are there, like hybrid and pure EV, single gear transmission and good fuel economy. So for good fuel economy, we will having some few calculations. So how to get the fuel economy. So in further slides, we will get that. Basically, major automotive systems are engine or motor, drivetrain, suspension, steering, brakes, instrumentation, electrical or electronic components, motion control system, safety. Safety means airbag, ABS, those comes under safety. Comforts and convenience, entertainment, communication and navigation. These are the systems available in a automobile. So components of EV. So in any electrical vehicle, these are the major and common parts in any of the manufacturer. So what are all the components? We will just see. Electronic traction motor, electric traction motor, power electronic controller, DC-DC converter, thermal system, that means cooling system, auxiliary battery to activate the main battery, onboard charger, transmission, charge port and traction battery pack. So these are all the basic components of an EV. So do we have any doubts in this particular slide?
No, sir, it's clear.
These are the types of motors used in EVs. So based on the battery pack capacity, vehicle architecture, the manufacturer will decide the types of motor to be used. So types of motors used in EVs: DC motor, permanent magnet brushless DC motor, BLDC motor, induction motor, permanent magnet motor, and switch reluctant motor. So switch reluctant motor currently we are not using in any of the EV. So these are the types of motors used in EVs currently. So for any motor, the below factors will be affected. So while selecting a drive motor, few factors to be taken into consideration. One is roll resistance, and second one is grade resistance, and third is acceleration force. So roll resistance is nothing but, so while initially we are giving an acceleration, the power from battery will directly go to the motor. So without any loss. So while transferring the power from motor to wheels, the wheels should not be rolled. So that is called roll resistant. So grade resistant. So grade resistant nothing but the quality of the power which resists the vehicle to be stable. Okay, so while the vehicle given high power, the vehicle should be in a stable condition. Na? So, and the third one is acceleration force. Suddenly, if we give the acceleration, the vehicle should move in the higher speed. So, these three are the main factors to be taken into consideration. So, is there any doubt in this slide?
No, sir, it was clear.
So, how we will calculate the traction efforts? So, total traction track to effort is equal to roll resistance, grade resistance, and acceleration force. So, for example, roll resistance is plus grade resistance plus acceleration force. If we add the three factors, then we will get the total track to effect. So going into the electrochemical in a cell, what are all the things available, how it is, how it looks inside the cell. So what is the integrity inside the cell, we will go into the in deep. So every battery will have an electrode, positive electrode and positive negative electrode, right? So the negative electrode sources electron on discharge. So there we are having two electrodes, negative electrode and positive electrode. So the negative electrode will work while the cell or battery is in discharge condition. So while discharging the battery, the negative electrodes will work. So while in the positive electrode sinks electron on discharge. In the positive electrons will sink. Sink means it will absorb the power. The electrolyte provides a medium of ion transport internal to the cell. So if we take a lead acid battery, we are having lead plates inside the battery. Many of the people will aware na, in this meeting we are having, many of the people are seeing the normal battery inside the vehicle, and inverters also available. I mean, most of the people in houses. So inside the battery we are having lead plates, and we are adding distilled water. Na? So distilled water is nothing but an electrolyte. Okay. So raw material used for cathode. So in any cell or battery, we are having cathode and anode as well as electrolyte. So for cathode is a positive charge carriers and anode is a negative charge carriers. So while constructing a cell, what are all the raw material using to construct a cathode? So these are the chemical compositions and raw materials used to construct a cathode. So lithium, nickel, cobalt, magnesium oxide. So currently in Indian manufacturers like Tata and Mahindra are using LFP, lithium iron phosphate cells. And for two-wheelers like Ola, they are using NCA batteries, lithium, nickel, cobalt, aluminum oxide cells for cathode. Okay.
Okay, sir.
So to construct a negative, that is anode, almost all the OEMs are using graphite material, silicon graphite and lithium metal anodes for anode. So you are all aware of the anode and cathode, na? Positive charge carriers are cathode, negative charge carriers are anodes. In between anode and cathode, there is an electrolyte which passes the power generated from anode and cathode. So, electrolyte, raw materials. Pindas are the interconnectivity between electrodes, both cathode and anode. Foil aluminum foil, anode slurry, copper foil with cathode slurry. So I think this is the chemical compositions in which a cell has been constructed with all these raw materials. Is there any doubt in these three slides? Please ask a question, sir.
Hello. Hello, sir.
Yes, please.
So can I get can I solve the question one of the?
Yeah.
So the cells in the battery we can connect in like a parallel and also for series now.
Yes,
So
yes.
which one is going to give more efficiency for the electric vehicles?
So, based on the architecture of the individual manufacturer, we are having cells constructed both in parallel and series.
Okay.
Uh,
Yeah.
Based on the requirement, the capacity of the battery, we will construct 2P, 2 cells connected in parallel, 3 cells connected in parallel, 4 cells connected in parallel. Like this, we will construct the battery. For each module, we are having 2P, 3P, 4P. That means P means parallel. 2 cells connected in parallel, 3 cells connected in parallel, 4 cells connected in parallel. Okay.
Okay.
So, just a minute, I will show you the construction.
Yeah, sure.
Is the screen visible?
Yeah, yes, sir.
So see,
But the slide had not changed, I hope so.
now
No, it's still showing raw material slide.
is it visible now?
Yeah, it's perfect now.
So this is for any cell. Either 2 types of cells are available in the market. One is prismatic shape and one is cylindrical shape. Okay.
Yes.
So we are taking one cell, we are taking another cell. So this is the 2 cells connected in parallel composition. Okay.
Yeah.
So while going to the 3 cell composition, so while increasing the cells, the capacity of the battery will increase. Okay. So if we add 4P, the cell capacity will be
Increased.
hello.
Yeah, okay, sir. Thank you for that.
So if we add another more cell in 3P, so the capacity AH of the battery will be 288. So like that, we will increase the capacity of the battery by increasing the number of cells inside a module. So number of modules increases inside the battery will result in the capacity or complete pack capacity will be increased. Okay.
Mm.
So can we go into the next slide?
Yeah, sure, sir.
So raw material for electrolyte. So basically we know everywhere, and we will know the distilled water, we are aware now. So for lithium-ion batteries, lithium salt, LiPF6, lithium hexafluorophosphate, lithium terafluoroborate. In an organic solvent, we will use this electrolyte in the lithium-ion batteries or cells. So nominal cell temperature will be 20 degrees centigrade. So what is power and what is energy? A cell stores energy in electrochemical form, which it can be later released to do the work. So initially the cell will store the energy in electrochemical form. Whenever the consumption will start, the power will come into the situation. So basically nominal voltages for each cell. There should be a highest voltage, maximum voltage, minimum voltage, and a nominal voltage for each battery or a cell. So for lead acid battery, nominal voltage is 2 volts. So for nickel metal hydride batteries or cells, it is 1.24 volts. LFP, lithium iron phosphate, it is 3.2. So for NMC batteries, lithium nickel cobalt aluminum batteries, it is 3.6. Lithium manganese oxide batteries, it is 3.7. So earlier in the earlier side, I have told you all that we are using LFP batteries only currently. So what is the nominal voltage for that particular battery is 3.2 volt only. So the lowest voltage is, minimum voltage is 2.5 and the maximum voltage is 3.6. So if the cell reaches 3.6, it will not allow the charge to, it not allow the charge. It will not charge. If the cell is below 2.5, the cell will not take the charge. Is there any doubt in this slide? So coming into the safety, so lead acid batteries are the highest safetiest batteries. So whereas NIMH batteries were safe, should not be overcharged, but while we giving individual cell charge, it will not be overcharged. LCO batteries, the temperature will run away at 150 degrees centigrade. For LMO batteries, the thermal capacity is 250 degrees. LFP batteries 270 degrees. NMC batteries, it is 210 degrees. So the temperatures are like this. So beyond the temperatures, it will not work, or it will become null voltage. So this is the series connection of the battery where the cells are connected in series. This is the parallel connection. Earlier in the earlier slide, we have saw the things in the battery 3P, 4P, 2P. So if we construct a battery, we need to take some points into consideration. So if we construct a battery, we need to assemble few cells in parallel, few cells in series. After the construction, we will give a battery management system controller to control and to monitor the cells. So what is cell balancing? So while keeping the charge, each cell will take some charge, but it will not charge completely. So for that, the cell balancing will be required. So for cell balancing, we require a battery management system for cooling to monitor all the battery related components. We require a controller to monitor the battery. Okay. So the battery management system will monitor the Can you please hold? So battery management system will monitor the each cell voltage, each cell capacity, what is the charge inside the battery cell, particular individual cells, the temperatures, everything inside the battery. So how can we calculate the power consumption? So we are having, for example, we are having a vehicle, electric vehicle. The battery pack capacity is 288 Ah and the battery pack maximum voltage is 73. So how we can calculate? So anyone can voluntarily come. Hello. Am I audible to all?
Yes, you're audible.
So, anyone come voluntarily to just do a small exercise? So you all are aware that power P is equal to V into I. You know the formula for power to know the power of that particular component or battery or a cell. So how to calculate the power consumption? We need to know the basic formula. So anyone? Anyone do the exercise? Can anyone? Hello. So okay. So here the battery pack voltage is 73.6 and the charge discharge rate of that particular battery is 288. For example, can anyone take it into the voluntary and come for a small calculation? So if the battery pack capacity is 75, then the battery pack amperes will be 288. So what is the final battery power capacity? Can anyone? Pack voltage into battery charge discharge rate.
So it might be 21,600 watts.
Yes. Exactly. So divided by 1000.
Yeah, so that we'll get per watt.
Sorry. Divided by 1000. So that is 21.6. The battery pack capacity is 21.6 kilowatt battery. The battery was 21.6 kilowatt battery. Okay. So for that particular battery, how we can calculate the how much power consumed while charging? So 21600 divided by 1000. How much? 21.6 units will be consumed per full charge of that particular battery. Okay. Do you guys understand the
Yes, sir. Please continue.
so to calculate that particular charge 21.6 into, for example, the cost per unit of the particular is 21.6. So 108 rupees is the cost for single charge of that particular battery. Okay, so we can calculate the power consumption for a particular battery like this. Okay. So how can we calculate the time for a battery to charge? For example, we are having a 30 kilowatt battery, 30 kilowatt hour battery. So in house we can give up to 3.3 kilowatt only for single phase. So total time to charge equal to total battery pack capacity divided by total input current provided. That is, for example, 30 kilowatt battery and we are giving an input of 3.3 kilowatt. So the total time taken is 9.9 hours. Okay. If the battery capacity is 40 and we are giving 7.5 kilowatt, then the time taken is 5.3 hours. So like that, the power to charge a complete battery, the time taken should be calculated in this formula. Okay. So basic block diagram of a battery management system. Okay. So what are all the parameters a BMS, battery management system, will monitor? We can see in this. Okay. So BMS will monitor the temperature of each cell, voltages of each cell, and power input and output of the battery, and the status of the battery. So you can see the block diagram. So what are all the parameters it will control? High voltage control. If there is any fluctuations inside the battery, it will control it will disconnect it through a contactor. Production overcharge or over discharge will not happen by disconnecting the charger or disconnecting the battery from the vehicle. SOC, performance management. So SOC is nothing but a state of charge. At what percentage the vehicle is going on, and what is the percentage of the battery remaining inside the vehicle. So diagnosis related, is there any, the state of health, state of life of the battery will be monitored by BMS. And also range estimation, based on the availability of the charge, how much kilometers the vehicle will travel, everything will be monitored by battery management system. So AC DC converter, already we have discussed earlier, OBC charger, onboard charger. So any battery will store DC current, direct current, okay? But we are giving AC current to the vehicle. So what a onboard charger will do, it will take AC power and converts into DC power, and that the DC energy which converted from AC will be stored in the battery. So DC converters. So we are in the previous slide we have learned that AC DC charger, that is OBC charger. So in that, what will happen, from outside grid the vehicle will be plugged in with AC charge, and in OBC charger the AC current will converted into DC, then stored in the battery. So for why did this DC converter required? Because in HV, high voltage battery, we are having high voltage, but we need to charge the auxiliary battery, small battery also, to wake up the vehicle, and for accessories like lights, horn, AC blower, stereo. For that DC 12 volts small charger, small battery we required na. So in IC engines we are having alternator or dynamo to recharge the 12 volts battery. So currently in EV we are not having any dynamo na. So to fulfill the dynamo requirement, we are using DC converter. This DC converter will convert high voltage to low voltage and recharge the auxiliary battery. DC AC inverter. In few vehicles we are having AC induction motor. So we have already having DC current in battery. So it is not used to run the motor which was equipped with AC induction motor. So another more DC AC inverter will be fitted in the vehicle to convert the DC power coming from battery to motor. So basic working of all components. So while acceleration, the controller will receive the accelerator pedal input, then it will take charge from the HV battery provided by AC motor, then transmission, then wheels. Basic AC charger connectors. So earlier we are having type 1, which was used by Tesla, European chargers and China based chargers. Currently we are using China based type 2 chargers in Indian market for Tata, Mahindra, BYD and MG. So these are the AC connectors, AC chargers, that is which we can keep it in our house. For DC charging connector, these are the connectors: Tesla DC, Cadmo, GPT, combination of AC DC. So see, combo 1, combo 2 we are using in Indian markets. So combo 1 we can see in the MG and BYD. Combo 2 we can see in Tata Nexon and coming Mahindra 400 XUV. So this is the main two connectors we are using in Indian market: CCS1 and CCS2. CCS2. This is the picture of combo 1 or CCS1, and this is the combo 2, that is CCS2. So mainly in any automobile industry, we are using in IC engines or in electric vehicles, we are using CAN system. CAN is nothing but an control area network, which a number of electrical controllers will be looped in a single line, where the communication will be transferred to all the controllers. So this is the schematic for CAN bus. So all the components: air conditioner, instrument panel, transmission, vehicle controller, everything, every controller is in a single loop. So any communication will be transferred to all the components at a time. So to check the range, I will show you the one picture. This is a cluster of one vehicle. So you can see the average watt hour. Okay. So this is the watt hour where highlighted in the red. Okay. Average watt hour. So we can calculate, based on this, we can calculate the range, how much range that particular vehicle is getting. Okay. So average watt hour we have seen in the earlier, and we know the battery pack capacity. For example, the complete battery pack capacity is 30 kilowatt. Okay. For example, 30 kilowatt divided by, what is the average watt hour? 83 into 1000. Okay. The range is 361 kilometers. Okay. So any doubts in this calculation? So in AC engines, we all are aware that kilometer per liter. So in EV, we will calculate watt hour per kilometer, liter per kilometer in IC, and watt hour per kilometer is in EV. So we can calculate the range with this formula. So general wiring harness, these are the two types of cables. Orange color are the HV cables, high voltage cables, and black are the signal or sensor cables or low voltage connector cables. So this is the session today. Hope you all are know the basics of EV. Is there any doubts in this session?
No, sir, it's clear. Please continue.
So this is the final slide. So is there any queries, doubts, or future real-time experience or real-time how the EV will help? Any doubts on these things? Hello. Is there any doubts? Can you please queries? Or we can close the session.
Hello.
Yes, yes, please.
Sir, someone are posting the questions in the chat, sir. Please can you check once?
Let's wait.
Hello, sir.
Yeah,
Hello. Sir, can I ask the questions which are posting in the chat box so that you can deliver them easily?
yeah, sure.
Yeah, definitely, sir. So one of the students is asking, sir, that we have the resources to manufacture the batteries in the high production.
Yeah, currently for manufacturing the battery or cell, we are not having resources like lithium. Lithium raw material is highly available in China. So currently, all the manufacturers are getting that particular raw material from China itself. So currently in India, we are having less, not less, no non-availability of lithium products or raw material.
Yeah, okay, sir. Next question I'm going to ask you. So one of the students is asking that, can you please show the wiring of the electric vehicle?
So this is the slide which you are having. So wiring we can't show because for different manufacturers they are having different architecture. But the standard color will be for HV battery, HV cables, high voltage supply. It is orange, and for sensors and low voltage supply, it is black sleeved.
Yeah, sir. Thank you for that. And so, can we know the capacity of a battery for electric
Yeah.
vehicle?
So yeah, already I have told you na. So the particular
Yeah.
capacity of the battery. So we need to know the voltage and ampere hours of the battery. Then we can know the capacity of the battery. I have already
Okay.
in that earlier calculation we have done na.
Yeah,
So
yes,
what
yes.
is the in that particular calculation, the voltage into ampere hours
Current.
of the battery is equal to capacity of the battery. That is kilowatt hour. Sorry.
Okay, sir. So the next question is how to overcome the battery heating issues.
Yeah. For high voltage batteries, many safety precautions will be there to open the battery because the cells are on the open condition, and uh, many precautions like hand gloves, electrostatic hand gloves, and so insulated tools are available in the market. So while using with under the surveillance of a battery engineer, we can open the battery with using all the insulated tools and gloves.
Yeah. Okay, sir. The next question is, will the lifespan, will it decrease the battery health by the year to year? Then how can we
Yeah,
overcome?
for any battery, not only for lithium, but also for lead acid also. So the cell degradation is there. So based on the company, they are giving some cell degradation values. Currently, the cell degradation value is of 0.25%. So cell degradation is obviously will be there, but the value will be 0.25% of the complete capacity of the battery per year based on the usage.
So there are any advanced batteries, sir, now at present which are running?
Currently, lithium silicon phosphate battery is going to come, but it is under trial run. So if that particular battery composition is there, the cost of the ownership will be reduced a lot. So currently it will take some time. I think 2025 there will be some good news or result for that particular battery, lithium sulfide.
Okay.
So basically, I have told three calculations. You can use the three calculations. You can get a basic idea of the current consumption, battery capacity, how to know the current consumption of a particular battery, and how to know the time to charge the complete battery, and for how the and also how to check the range of the battery. So for example, 30 kilowatt battery, how much kilometers the range will come. So all these three we can get through the particular calculations, what I have told in the class.
So there is an interesting question one of the student had posted.
Yeah.
He's asking that will we able to manufacture in our future to make the electric vehicle by using the solar plate providing on the top of the
No.
car?
So we can't charge discharge at a time. Okay. So we can charge, either we can charge or we can discharge a cell. Both the charge and discharge we can't do at a time. So the we can charge the battery with that solar panel, but in running it is not possible. While discharging the battery, it is not possible.
So how can you support like piezoelectric sensors
Yeah,
regarding this electric vehicles?
yeah, piezoelectric, piezo sensors are piezoresistive are there, piezoelectric are there. Okay, so currently piezoresistive we are using in airbag depletion, like impact sensor. So we are using piezoresistive in as an impact sensor. While there is any external impact, the resistance value will be vary, and that information goes to the particular component controller, so that then the action will be happen. So currently we are using piezoresistive in airbag impact sensor.
Okay, so there is another question for you. So like we are discussing about which cables, like underground cables or overhead power cables.
So orange are the power cables where high voltage will be transferred, whereas in black shield cables only the signal from sensor to component or component to sensor or controller to component will be transferred.
Okay, sir. Sir, is there any chance to affect the battery from atmosphere conditions, sir?
Can you repeat the question again?
Like, is there any chance to affect the effect of the battery from atmosphere conditions? I think
Yeah,
it might be in interior
yeah.
design.
So obviously external factors like temperature will affect the battery. So because of that only we are using coolant controlled or coolant cooled batteries or air cooled batteries. Currently we are having air cooled and coolant cooled. So each cell is equipped surrounded by coolant to cool the battery. Whenever the battery temperature reaches 35 degrees, that is the room temperature, right? The coolant will be circulated around the cell and the cell will be come under temperature. Whereas in air cooled, there will be a AC system provided inside the battery, which will cool the battery whenever the temperature reaches high.
Yeah, okay, sir.
So
So
two
is the
types
same
are
principle.
yeah, two types of cooling systems currently we are using. One is air cooled and second one is water cooled or coolant cooled.
Okay, sir. Do we do the principle do the same principle applicable for the electric trains also?
Sorry?
Do the same principle like battery protection is same for the electric vehicles too? Like
Yeah.
electric transportation of the
Yes,
railways.
yes. So while running, the motor will also get high temperature, na?
Yeah, yes.
So for motor also the coolant will be transferred in running. So both two cooling systems will be available. Two coolant circuits.
Okay, sir.
One for battery and for motor. One for motor. While charging the motor coolant system will bypass and it will cool the charger, OBC charger, onboard charger.
Yeah, okay, sir.
Any queries more?
So someone is asking like, do the electric cars break down more?
Yeah, electric car will break down because of few reasons. So currently the breakdown ratio has been decreased because in Indian market in 2019 only many of the manufacturers production has been started and we can see on roads. So from there the manufacturers changed many component designs based on the field input or customer feedback or customer inputs. So currently the breakdown ratio has been decreased and the problem since in EVs came down.
Okay. So can you give an overall description about how will be the electric vehicle is going to rule the world in the coming years?
The coming years, you can see currently I already told that sale ratio for 100% sale ratio, the EV in India itself, it is reaching almost 50%. So if someone sell 100 cars, in that almost near to 50 cars are selling, they are selling only EVs like Tata, MG, and BYD is a Chinese product where they are having only EVs. So in coming future, EV rule out the automobile industry, and the cost of the ownership is very less. Because of that reason, every individual will take the EV, will having the interest in EV. In further, the chemical compositions of each cell is getting, so the cell cost also getting reduced in further.
Yeah, okay, so there are lots of opportunities for the
Definitely,
people who had done
definitely.
in the core subjects, I
Yeah,
hope.
yeah. Already in this course we have saw battery management system, that is a controller which was designed by electronic team, electronic and ECE students will design the battery management system, and the motor that was designed by triple E team students, and body motor, transaxle or gearbox. Remaining all the components were manufactured or designed by mechanical students or automobile students. So see how much future will be there
Yeah, so,
by
so your
increasing
answers
all.
are your
Earlier in
answers.
automobile industry, there is no future for ECE students and ECE and triple E. So currently, while electrifying the automobile industry, all the three department students will get more opportunities.
Yes, sir. So there are lots of questions for you because your answers are conveying on a right path to the students. So there are some questions. Can I?
Yeah, please.
Um, like split battery systems, we can do the charge and discharge
Yeah,
at the same time. They are asking.
we can't do charge discharge at a time.
Okay.
So it is practical. It is not possible to charge at a time discharge. Either we can charge or we can discharge. Only one activity will be possible. Hello.
Yes, sir.
Yeah. So any questions more?
Yeah, sir, they are posting. They're typing in the chat box. Just a
Yeah,
minute.
sure. We'll wait.
Yeah. Okay, sir. So there is a question, sir. What are the
Yes.
limitations of electric vehicles? They are asking about.
Sorry,
What are the limitations of electric vehicles?
regarding which limitations? So the basically currently in market, the range is the major feedback for electric vehicle. The range which provided by all the manufacturer currently available in India is only about 400 to 500 kilometers only. That is the only limitation having in electric vehicle.
Okay. Hello, sir.
Yes, please.
There are no any questions, sir. Do you want to deliver anything to our students, sir, as a final review to today's session?
Yeah. Electrical vehicle market is going to be a big blast in coming 2-3 years. You can get almost a light commercial and heavy commercial also we are getting. In further already in the market we are having electrical buses also. Telangana government also implemented around 5 to 10 electrical buses. So as a trial run, in further we are getting almost all the vehicles, commercial, passenger, and light commercial vehicles are we are getting electrified, and in further future uh, government will also announcing good benefits for EV to encourage the EV manufacturer and also to the common people. So coming EV market is very high and the opportunity is also very good. So try to get the more information about EV.
So I think if we'll do any internships or training on the electric vehicles, so
So
there might be a bright future for us.
sorry.
If we do any summer internships or any
So
courses in the
according to
electric vehicle.
me, hand-on experience will help more to know about the electrical vehicle, and we can gain more knowledge while seeing the electrical vehicle components directly.
Okay, so
This is the just basic class which you can know what are all the components inside a battery and how the connections, each individual cell will be connected inside a battery, and also a small introduction of EV vehicle. So we can get more knowledge only when we see the particular electrical vehicle, any of the vehicle and the components physically, we can get more knowledge.
okay, so this was a really wonderful session for us, creating the hopes to many of the people who are done their bachelor's in the core subjects. Because nowadays we are seeing currently the recession is going on. So
Okay.
completely IT sector is going to be in the losses. So you you provided us like another opportunity for
There
us. There
is
is some other ways to us.
there is fluctuations in IT and computers or software side, but coming days, electrical vehicle or a manufacturing people are investing more and more on EVs only. So the opportunities will be very high and the employment will be very high. Particularly in Indian market, we will get more opportunities.
Yeah, okay, sir. Okay, sir. Then thank you to having a wonderful session with us.
Thank you. Thank you.
And thank you everyone for making the session very wonderful. And I hope you had gained lots of experience, and also at the same time, your doubts are get cleared by having this session with you all. I hope so. And once again, thank you everyone. We are going to end the session now. Is there are still any doubts?
I think no one have the doubts, I think. Yeah, Sumant?
Hello?
Yeah. Sumant and Nitya, thank you so much. And I think we can stop the session, right?
Yes, sir.
Yeah. Thank you so much, guys. Yeah.
Yeah, thank you, sir.
Thank you.
And thank you, everyone. Please give valuable feedback to us, and next time we can do more kind of session with this feedback. Thank you so much.
Maya